Good morning, students. Myself, Dr. Rajwant Kaur, lecturer, Government Polytechnic College for Girls, Amritsar. Today's topic is water and its hardness. Water, as we all know, it is the most abundant commodity, and because of its large amount of presence on our planet, that is Earth, the Earth is also known as a blue planet. Approximately 74% of Earth's surface is covered by water, but out of this water, 97.3% of the total water which is available on Earth, that is locked in oceans, and it is too saline to drink, and as such cannot be used for agricultural and industrial purposes also. Water is not only required for the well-being of the plants and animals, it is also required for various industrial purposes also, and the most important industrial use of water is in the steam generation. The water which is available for domestic, agricultural and industrial purposes, that counts only 0.3% of the total world's total resources, water resources, which man can tap, means which man can utilize it for domestic, agricultural and industrial purposes. Now you can well imagine how scarce is water which is available for various uses by the man being. Now coming to various sources of water. Basically the water which we use or which we have can be grouped into two categories. One is the surface water and other is the underground water. Among the surface water we have various options like this: rainwater, river water and sea water. Now rainwater, as we all know, that water is constantly evaporating from the surface of the sea, rivers and lakes. Its vapors go to the higher altitudes where they condense and then fall down as rain. Now it is the main source of all water, whatever is present in the oceans, rivers and lakes. This is all due to, we can say, rainwater. No doubt it is considered as the purest form of naturally occurring water, but when the rain comes down or falls down on the earth, it dissolves some of the impurities which are present in the atmosphere, like sulfur dioxide and the oxides of nitrogen as well as carbon dioxide it has. Now the major use of rainwater is in medicinal preparations. Now another surface water source is the river water. Now the water which is formed by the melting of the ice, melting of the snow on the mountains, and also from the rains that flow down in the form of rivers. Now this water, as it flows along the surface, it dissolves certain chlorides, sulfates, bicarbonates of sodium, potassium, calcium, magnesium, etc., as well as it has suspended impurities like sand, fine sand and rock, and it carries all these dissolved impurities as well as the suspended impurities from the places through which it passes. Now sea water, this is the biggest source of water, but the tragedy is that most impure form of water. On an average, it contains 3.5% of the dissolved salts, and out of this 2.6% is sodium chloride. Now we can have a look that Dead Sea in Israel has its name because no life, no sea life exists in this sea. The reason behind is that it has 4.5% of the dissolved salts, which make it unfit for the sea life to exist. Now, another surface water is spring water. Large amount of rain water percolates deep into the earth through permeable rocks. Now, this water during percolation, all the suspended impurities, suspended matter is left behind, and further the organic matter is decomposed by the bacteria, and as such we can say that the water which has percolated, that is quite pure. But at the same time it dissolves many substances which, but these substances generally they have great medicinal value. They can be used for curing various diseases, especially the skin diseases. Now, when this water which percolates through the soil, through the rocks, it reaches an impervious rock, it is prevented from proceeding downwards further, and it gets collected in the form of a pool. Now, when this water, this collected water finds an opening, it rises to the surface in the form of spring water. Now, the most important sulfur water, which contains hydrogen sulfide and other sulfur compounds, that is useful in curing skin diseases, and the saline water, which contains magnesium sulfate, sodium sulfate, that acts as a good laxative. Now, the most important source of underground water is well water. There are beds of water under the surface of the earth, and when we dig through the layers of the earth, well water is obtained. Now, this water is generally clear and it contains very small amount of dissolved impurities. The reason is same as for the lake water or the spring water. The reason is that it is the percolated water, so it doesn't have any you can say suspended impurities in it as such, and because of its purity it is used for drinking and irrigation purposes. Now, we are talking about the various forms of water, like that is pure, that is impure. Now, what are the most important impurities which are present in water? They can be, the impurities which are present in water can be grouped into two categories. One is the dissolved impurities and the other is suspended impurities. Now, the dissolved impurities include certain gases like carbon dioxide, oxygen, oxides of nitrogen, and salts like bicarbonates, chlorides, sulfates of calcium and magnesium. These are all dissolved impurities which can be present in the water. Now, the suspended impurities, they can further be grouped into two categories. One is the inorganic suspended impurities and the other is organic suspended impurities. Inorganic suspended impurities, they include clay and fine sand particles which are present in the water, and the organic impurities, they are generally in the form of vegetable and animal waste or other matter which is of organic origin, means derived from either from plants or from animals. Now, the impurities can also be grouped under the heading as colloidal impurities and bacterial impurities. Colloidal impurities, they are the finely divided clay and silica. Organic waste products can also be in the form of colloids. complex proteins and coloring matter, they are all in the form of, they all form a colloidal solution with water, and the water does not appear clear when such impurities are present in water. Bacterial impurities, they include living bacteria, microorganisms, and other forms of animal and vegetable life in water. Now, sometimes we come across a certain type of water that doesn't form lather easily with water, easily with soap. Now, the reason behind is that such a water contains uh, salts of calcium and magnesium, which prevents the water to form leather with soap. Now, this characteristic of water, due to which it does not form leather easily with soap, is known as hardness of water. Now, this hardness, as I have already told you, that is due to, mainly due to the presence of calcium and magnesium ions. Now, why the water which contains calcium and magnesium ions in it is hard? That is, the reason behind is this, that the calcium and the magnesium ions, they react with the sodium salts of long chain fatty acids, which are present in the soaps, to form insoluble calcium and magnesium salts of long chain fatty acids. Now, this is soap, that is sodium stearate is the formula, as you can see. When the water containing calcium chloride is treated with such a soap, then the calcium of the calcium chloride reacts with the sodium salt of sodium stearate. It results in the formation of calcium stearate, which is in the form of an insoluble precipitate. Now, most of the soap which we add to the water, that is consumed by the calcium and the magnesium ions, and as such is not available for cleaning or for leather formation. Now, on the basis of the hardness causing substances, or the hardness type of the hardness which is present in water, water can be categorized into two categories. One is soft water and other is hard water. Now, water which does not have calcium or magnesium ions in it and can easily form leather with soap solution, then such a water is termed as soft water. On the other hand, if the water contains calcium or magnesium ions in it, either in the form of calcium carbonate, calcium chloride, calcium sulfate, then magnesium sulfate, magnesium carbonate, etc., then such a water is termed as hard water. Now, there are two types of hardnesses. Depending upon whether we can remove it simply by some physical method or not, the hardness can be temporary or permanent. Now, temporary hardness is due to the presence of bicarbonates of calcium and magnesium. Now, this is known as temporary hardness because it can be removed by boiling. Now, what happens when we boil hard water containing calcium bicarbonate or magnesium bicarbonate? Now, on boiling, these bicarbonates, they decompose to give you carbonates, water and carbon dioxide. Now, this carbonate, calcium carbonates, they are insoluble and are removed, and the resultant water is now soft, means it does not have the hardness causing substance in it. Now, carbonates, as I have already told, they are being insoluble and can be removed. On the other hand, permanent hardness cannot be removed simply by boiling. Here we have to treat water with certain chemicals in order to remove this hardness. Now, the cause for permanent hardness is the presence of chlorides and sulfates of calcium and magnesium. Now, when the hardness causing substance are chlorides and sulfates of calcium and magnesium, then the water is termed to have permanent hardness, because such type of hardness cannot be removed simply by boiling. Now, when we say a particular sample of water is hard, now what is the measure for such hardness, or in technical terms, what is the degree of hardness? Now, hardness of water is always measured in terms of calcium carbonate, whether it is due to bicarbonates, chlorides, sulfates of calcium or magnesium. Now, why this standard calcium carbonate is taken? The reason behind is that it is the most insoluble salt that can be precipitated in water treatment. And another reason is that the molecular mass and the equivalent mass of calcium carbonate are 100 and 50 respectively, and as such the calculations become simple when we take this as the standard. Now, defining the degree of hardness, or how can we define the degree of hardness, is that it is the number of parts of calcium carbonate equivalent hardness per definite number of parts of water. Means how many parts of calcium carbonate equivalent. Now, I am using the term calcium carbonate equivalent. The reason behind is that it is not necessary that the hardness of the water is only due to the presence of calcium carbonate. It can be due to the presence of bicarbonate, calcium chloride, or calcium sulfate, magnesium chloride, and so on. Now, we have taken the calcium carbonate equivalent. Now, how can we calculate the calcium carbonate equivalent? That is by having a multiplication factor for converting the hardness into equivalents of calcium carbonate, which is obtained by dividing the molar mass of the concerned the molar mass of calcium carbonate with the molar mass of the hardness causing substance. For example, if we want to calculate the equivalents of calcium carbonate when the hardness is only due to calcium bicarbonate, then the multiplication factor for converting this into equivalents of calcium carbonate, that will be 100 divided by 162, because 162 is the molar mass of calcium carbonate and 100 is the molar mass of 162 is the molar mass of calcium bicarbonate and 100 is the molar mass of calcium carbonate. Now, similarly, you have a list on the your display board that is given the molar mass of various substances which are present in hard water and are responsible for the hardness of water, and then the multiplication factor for converting it into equivalents of calcium carbonate. Now, there are various ways of expressing the degree of hardness. As in the previous slide I have shown that it is the number of equivalents of calcium carbonate per number of parts of water. Now, depending upon how many parts of water we have taken, we can have 4 different types, 4 different units of hardness. These are parts per million, abbreviated as ppm, Clark's degree, then French degree, and milligrams per liter. Now, how can we define parts per million? This is the number of parts of calcium carbonate equivalent hardness present per million parts of water. Now, when 1 part of calcium carbonate equivalent hardness is present in 10 raised to the power 6 parts, that is million parts of water, then we say that the hardness is 1 ppm. So, 1 ppm is when 1 part of calcium carbonate equivalent hardness is present per 10 raised to the power 6 parts of water. Then degree Clark, it means when 1 part of calcium carbonate equivalent hardness is present in 70,000 parts of water. Means if we want to express the hardness in terms of degree Clark, then it can be defined as number of parts of calcium carbonate equivalent hardness present per 70,000 parts of water, or 1 degree Clark is 1 part of calcium carbonate equivalent hardness present per 70,000 parts of water. Now, degree French is when number of parts of calcium carbonate equivalent hardness present per 10 raised to the power 5 parts of water, means it is the number of parts of calcium carbonate equivalent hardness which are present in 10 raised to the power 5 parts of water. For example, if we want to say that the hardness is 1 degree French, then it means that 1 part of calcium carbonate equivalent hardness is present in 10 raised to the power 5 parts of water. And the last or the fourth expression for the degree of hardness is milligrams per liter. It is defined as the number of milligrams of calcium carbonate equivalent hardness present in 1 liter of water. Now, 1 milligram per liter means when 1 milligram of calcium carbonate equivalent hardness is present in 1 liter of water. Now, what's the relationship between various units for the degree of hardness? That can be 1 ppm means 1 part per 10 raised to the power 6 or 1 million part of water. 1 degree French means 1 part present in 10 raised to the power 5 parts of water, and 1 degree Clark means 1 part present per 70,000 parts of water. We can say from this expression that 1 ppm is equal to 0.1 degree French and 0.07 degree Clark. Now, this relationship can be used for conversion of 1 unit of degree of hardness into the other for expressing. Now, regarding the relationship between 1 ppm or the ppm scale and the milligrams per liter, 10 raised to the power 1 milligram per liter means 1 milligram present in 1 liter. 1 liter is 1000 milliliter, or we can say that when 1 part is present in 10 raised to the power 3 parts, 1 milligram. Now, 1 milligram is equal to 1 upon 1000 grams, or we can say that when 1 part is present in 10 raised to the power 6 part. So, 1 ppm is equal to 1 milligram per liter. Now, how can we estimate hardness of water? Now, generally the estimation of hardness of water is done by complexometric titration using standard solution of disodium salt of ethylene diamine tetraacetic acid, that is abbreviated as EDTA. Generally, EDTA refers to disodium dihydrate salt of ethylene diamine tetraacetic acid. Now, this is a tetraprotic acid and its disodium salt dihydrate is represented as Na2H2Y 2H2O for dihydrate. Now, when we have aqueous solution, then this EDTA gives us sodium ions and a strong chelating ion which can be represented by H2Y 2 negatives. Now, with calcium and magnesium, this chelating ion forms stable complexes. Now, how can we estimate the hardness? Equivalence point is determined by using areochrome black tea indicator. Now, what is the role of this indicator? Areochrome black tea, which can be represented as EBT, it forms a wine red colored unstable complex with calcium and magnesium ions. Now, when we have hard water and we put EBT into it, hard water means water containing calcium or magnesium ions. Now, when this water is treated, when a drop of EBT is put into this water, it gives a wine red color, which is due to the formation of calcium EBT complex or magnesium EBT complex. These complexes, they are unstable, means this reaction can be reversed, means the areochrome black tea can be set free from the calcium and the magnesium ions when another chelating ion is present in the solution. Now, when such a solution is containing this EBT indicator is treated with EDTA, then what happens is the EDTA reacts with the calcium and the magnesium ion to form the stable complexes, and at the equivalence point the EBT is set free because the metal EBT complex, which is red in color, it reacts with EDTA to form stable complex of metal EDTA, and the areochrome black tea indicator is free now, which gives a blue color. So, the end point in this type of titration is from wine red to blue. Now, when this is obtained, then the general calculations they are done in order to get the degree of hardness. Now, the question arises, what are the various disadvantages of using hard water? Now, if we have hard water, then why this is not fit for various purposes? Now, the various disadvantages of using hard water in domestic uses, the most important one is the wastage of soap, because the large amount of soap is wasted in forming precipitates with the calcium and magnesium ions and does not form leather. As such, the cleaning action of soap is not up to the mark. Then the spoiling of clothes, the precipitates of these calcium and magnesium salts of calcium and magnesium soaps, the precipitates which are formed by the action of calcium and magnesium ions onto the soap, that forms a layer onto the clothes, which results in the dullness of the colors, or the colors are faded and the clothes, they are spoiled. Now, disadvantage of using hard water in cooking is that the pulses and the other vegetables, they take more time in cooking than in the soft water, and encrustation in kettles, that is another disadvantage of using hard water when for preparation of tea or for some heating water. Now, in paper industry, the hard water, if used, that reacts with the chemicals which are used in paper industry, and as such the color of the paper is not up to the mark. And further, in case of textile industry, when hard water is used, then the color and the shades, they are not good when the hard water is used. Even the soap consumption in textile industry, that has also increased. In beverage industry also, the hard water is not, as it is not good for drinking, so in beverage industry it is not required. And the major drawback of using hard water is in boilers, because as I have already told you that the